Imagine tiny robots working together like swarms of bees. Recent research captures this idea by utilizing sound waves for coordination. An international team of scientists has designed micro-sized robots that communicate acoustically, emulating nature's efficient systems. These robots can self-organize into swarms, moving as one, which opens up new possibilities. For instance, they can explore disaster zones, clean pollution, or deliver medication inside the human body. Igor Aronson, the study lead, emphasizes this technology's potential to solve complex challenges. The researchers published their findings on August 12 in Physical Review X. Their model reveals that sound communication enables these robots to adapt and navigate tight spaces. If damaged, they can reform, showcasing impressive, self-healing abilities. This resilience offers advantages, particularly for surveillance and sensor applications. Aronson notes, this represents a significant leap toward creating smarter, more resilient microrobots. Simulating acoustic communication helps the robots synchronize and respond to their environment, similar to how fish schools or bird flocks behave. While this research is still in the model phase, the outcomes indicate that achieving collective intelligence in robots is viable. Simple circuits, comprising motors, microphones, and speakers, can lead to complex behaviors. The robots synchronize their movements based on the acoustic signals, creating coordinated swarms. This study marks a breakthrough in the growing field of active matter, focusing on self-propelled microscopic agents. It demonstrates that sound waves can efficiently control these microrobots, replacing traditional chemical signaling methods. Aronson emphasizes the benefits of acoustic communication. Sound waves propagate faster and farther almost without loss of energy. This breakthrough harnesses nature's principles, paving the way for future applications in various fields. In summary, the integration of acoustic signals in robot swarms opens new opportunities. By mimicking nature's coordination, these robots can tackle some of the world's most pressing problems. Stay tuned for more updates on this exciting research.